is in the air, its potential energy increases and it therefore requires propulsion. When an airplane accelerates, its kinetic energy increases and likewise it requires propulsion.
The law of energy conservation asserts that potential energy difference equals negative kinetic energy difference minus work to overcome drag plus propulsion work.
A sailplane can find and maintain a constant velocity by diving, whereby its potential energy loss balances the work to overcome drag without the need for propulsion.
If a force acts on a beam at some distance from the fulcrum, a moment of force is generated and the beam starts to rotate.
If the described moment is counteracted by a smaller force at the same distance in the opposite direction from the fulcrum, the resulting moment is lower. In any case, the beam again starts to rotate. For each counteracting force, there is exactly one distance from the fulcrum for the generation of a moment of the same magnitude and opposite direction as the original one to balance the beam. If both forces are acting on the same side of the fulcrum, they have to be oriented in opposite directions. Obviously, the distance has to be selected appropriately to balance the beam. If the moments are balanced in respect to the fulcrum, the forces may be added in the following way. The magnitude of the smaller force is subtracted from the magnitude of the larger force. The resultant force is oriented in the direction of the larger force and the line of action passes the fulcrum. An airplane that moves freely in the air will always roll around its center of gravity when unbalanced forces act upon it, generating moments. Here, lift is of particular interest. In level flight, lift acts on the wings upon a point around the middle of the fuselage. If, in level flight, the center of gravity at which the airplane weight acts is found at a location behind this position, a moment will be produced which will turn the nose of the airplane upwards. By contrast, if the location at which the weight acts is forward from that at which lift acts, the exact opposite will happen and the nose of the airplane will turn downwards. So, in order for the airplane to be able to follow a stable, straight flying path, the moment just described needs to be compensated by the so-called horizontal tail plane, which is the wing-like lifting surface below the tail of the aeroplane. The function